Very good morning to all of you. So in yesterday's class, we discussed about the concepts of integration, and today we will be seeing the applications of integration in physics. Now we have done differentiation, we have done integration, the mathematical concepts. Good morning once again to all of you, and please now again, since the class has started, again in the beginning I am asking you all to refrain yourself from any unnecessary chats or whatever is not pertaining to the class. Kindly don't be involved in that, otherwise you will be simply be removed from the classroom. So better focus, like most of the students who are focusing, and I hope they are understanding also what is going on, because if not now, then soon, very soon, when your regular classes will start, then you will see that yes, these all applications that we studied during the online classes, these are actually going to be beneficial for us. We are able to solve questions fast, right? So better that if you are attending the class, then at least maintain some dignity for there. Now, as I was saying, we saw differentiation, integration, the basics, the concepts which are going to be used, how we are going to use them, we saw yesterday. Now, if you forget any of the formulas, I have already told, you can either take screenshot or you can write down from YouTube. Those who are new, you can go and check the videos and write all the important points which we have discussed in form of notes. So, when we see the application of calculus in physics, so when we take motion, if you talk about motion or kinematics, we will have two forms or important motion equations. We are talking of the general equations of motion. Now when I am saying general equation, means acceleration can be constant, variable, I don't know, general. So when we write the general equations of motion, we will have two forms. One is the differential form and one is the integral form. So differential form and integral form, when we are saying a body has its position as a function of time, so as discussed earlier, change in x is called as displacement, x final minus x initial, and dx by dt or ds by dt will give you instantaneous velocity. This was our first equation. If velocity is a function of time, then dv by dt gave you acceleration. This was our second equation. So we have to understand that which equation to use where. And if velocity was a function of position, then acceleration by chain rule we got v dv by dx. These were the three equations which we use in differential form. Now, next we come to the integral form. As I told, integration is just the reverse of differentiation. So when we want to go from position to velocity to acceleration, we keep on differentiating. And when we want to go from acceleration to velocity to position, then we keep on integrating. So yesterday whatever we saw, based on that, we can say, if suppose acceleration is given as a function of time, suppose acceleration is a function of time. Now you see over here, we know that acceleration is dv by dt, acceleration is dv by dt. So since acceleration is dv by dt, that means if I take dv on one side, I can multiply acceleration like this. dv by dt is acceleration, so dv is equals to a dt Now, if I take in any time interval t1 to t2, here I can write v1 to v2. Now, yesterday I told you that when you are writing dx, integration will become x. That means x2 minus x1. So, if you are writing dv, it will become v. So, dv will become v. So, when you will put the limits I showed yesterday, v2 minus v1, that is change in velocity, it will be found by integrating acceleration with respect to time. If you integrate acceleration, you will not get velocity beta, you will get change in velocity. So this is called a change in velocity. So I think again unnecessary chats are going on. Some students, I don't think you are students also, you are hell bent on wasting your time as well as the time of others. So better, because if I want to discuss something and make sure that students are putting efforts and whatever I ask, you reply to that. So again, spraying insecticides and pesticides is very important. So yes, I think for the time being, few harmful insects have been eliminated from the classroom. So coming back, change in velocity is integration of acceleration with respect to time. So remember, when we have position, we get velocity by differentiation. When we have velocity, we get acceleration by differentiation. But if you integrate acceleration with respect to time with limits t1 to t2, you will get change in velocity. You will get change in velocity. Please focus on the class instead of again this hi, hello and all. We have already wished everyone good morning and all. Now we are focusing on the class. Look over here. So v2 minus v1, change in velocity is integration of acceleration with respect to time. Apart from this, what are the other equations that you are going to use for integration? For integration, we can also see the next one is, if acceleration instead of t, it is given as a function of x. If acceleration is given as a function of x, so you can see from here, this equation a is equals to v dv by dx. So if I get acceleration as a function of x, when I will write all this, you can take a screenshot so that when we are using in questions of physics, you understand what we are doing exactly. If acceleration is a function of x, then we have two equations of acceleration we know, one is dv by dt and one is v dv by dx. So we can go by the form v dv by dx. Now you may think that, sir, why are we not using acceleration dv by dt? If you use dv by dt here, you will have three variables, velocity, time and x. But for integration, we need two variables. So that's why I am writing acceleration as v dv by dx. If I write v dv by dx, so from here I can take v dv on one side and a will be multiplied by dx. Now put the symbol of integration. After cross multiplying, a dx is v dv. Now put the symbol of integration. Suppose you were initially at position x1, now you came to position x2. Suppose your initial velocity was v1, now it became v2. So you know, we have seen x to the power n formula. X to the power n integration is x to the power n plus 1 by n plus 1. So v with respect to v means v square by 2. V with respect to v will become v square by 2. So what you will get here? By integration you will get v square by 2. Now you have limits over here, v1 and v2. This side I will keep it as it is, x1 to x2. So finally we can write that when you integrate acceleration with respect to x from x1 to x2, you get nothing but put first v2 final velocity square minus initial velocity square by 2. Another very important form, whenever we have acceleration as a function of x and you integrate acceleration with respect to x, if you integrate acceleration with respect to x, you will get v final square minus v initial square by 2. If you integrate acceleration with respect to time, then you get change in velocity, v2 minus v1. These are velocities. Vectors, they can be positive, negative, both, mind it. But if you integrate acceleration with respect to x means position, then you will get v final square minus v initial square by 2. So this one is the second important equation for integration. Differentiation equations you already have. If you wish, right here also you can take a screenshot so that both are available with you when we are discussing questions. So left hand side, right hand side, the entire board you can take a screenshot so that you don't get confused which equation we are using where. I hope you have done it. So let's now see another important integration. Okay, another important integration. Now we saw acceleration is a function of time. What if velocity is given as a function of time? If velocity is given as a function of time, then we know that velocity is nothing but dx by dt. So here I will take dx on one side and v dt on one side and I will integrate. So t1 to t2, here I will write x1 to x2. But I know dx will become x, so I will put first x2, then I will put x1, which is integration of velocity from t1 to t2. But we know what is x2 minus x1, it is change in position, which I told is simply displacement. Change in position is called as displacement. So here what we can simply say, the third important integration formula, when we have velocity integrated with respect to time, if you integrate velocity with respect to time from t1 to t2, you get displacement in that interval. You will simply get displacement in a time interval. So you have to understand is as per the question what they are asking. Whether they are asking velocity acceleration, that means you have to differentiate. And if they ask you change in velocity if acceleration is given, or the displacement if velocity is given, then you have to remember that we have to integrate. So it is not that randomly we will put integration, differentiation everywhere. It is as per the situation, some data will be given, based on that you can find whatever is being asked. So we have this collection of equations for general motion. These are the equations. Now we will see how we can apply them, and first and foremost what I will do, I will derive the equations of uniformly accelerated motion, so that you understand that by calculus method how we are getting those equations, s equals to ut plus half at square and all. You will understand that. Clear? So what all rules I have told in integration, if you had seen them, if you have written them, and what I wrote today, if you are able to see them, had a screenshot of them, then you will understand how we are proceeding. Okay, let's see. So coming to equations of uniformly accelerated motion by calculus. So suppose we are considering t equals to 0, a particle is at moving along x-axis and here it was at a position, I don't know what is the position, it can be origin, wherever it can be. So wherever it can be, here it had a velocity, this velocity over here, initial velocity, let's call it as u. Now it is having a constant acceleration, acceleration is a constant here. After some time, at t equals to t, it reached a position, let's call it as x. And here, let's take the velocity as v. So initial velocity was u and here we are taking the velocity as v. Now, as I said, as per the situation, you can see acceleration is constant. So what we can say, first equation I told, when you integrate acceleration with respect to time from t1 to t2, I said you get change in velocity, right? Change in velocity means v final minus v initial. Now here acceleration I have taken constant. So I had told in integration, whenever we have a constant you can take it outside. So acceleration will come outside and we will have integration of dt. I told dt integration nothing, it is simply integration of 1. So it will become a, dt will become t, that is t2 minus t1. And this side you have v final minus v initial. Now substitute the value. What is v initial? I have taken initial velocity, I have taken u. Final velocity I have taken v in this interval. Initial time I have taken as 0 and final time I have taken as t. So from here only we see v minus u becomes at or v equals to u plus at. This is our first equation. Now in this, remove Kriti, Prasatha. Now here v is equals to u plus at is nothing but a function of time. So v velocity you can see is changing with time, is a function of time. When v is a function of time, so we saw that if I integrate velocity with respect to time, I said you get change in position, which is displacement. From t1 to t2, if I integrate. So if I want to write displacement, it is x final, that is change in x is x minus x initial. X initial I had taken as x naught, x minus x naught. This value will be integration of velocity. What is velocity we have taken? We have taken u plus at dt from t1 to t2. t1 I have taken as 0, t2 I have taken as t. Now if you remove from here all this when sir holidays, for you I am giving holiday just now. Please send him to holiday. Who is this? Satvik Creativity. So creative people are not allowed here. You can enjoy your holiday now. So displacement, which is change in position. Now see the integration. First term u is a constant, u dt will become u, dt will become t. Next term a is a constant, comes outside, integration of t with respect to t will become t square by 2. If you put the limit also, no problem, 0 to t, 0 to t. So you will get displacement is ut plus half at square, and it is actually change in position. Displacement is change in position. So x minus x naught, this value is only called as the displacement. So wherever you were at, you find displacement. If you don't focus in the class, it will be obviously confusing. If you are thinking about other things in the world while listening to the class, obviously it will be confusing. So I have told what to do. Acceleration is constant, velocity I have to find. So integrate acceleration, we get change in velocity. Once we get velocity, it is a function of time. Integrate with respect to time, you get change in position. Change in position is called as displacement. When I started the class, I wrote everything. If it's still confusing, beta, then that means you have to come out of your confusion by focusing on the class and leaving everything what is going on in the world outside you. Just listen to the class, then you will be able to understand. S is ut plus half at square. Now there is one more equation which is v square equals to u square plus 2as. Let's try to see how we get that. Now for that we can use the third equation of integration. What is that? Also I told acceleration, if I use v dv by dx, so I told you when you integrate acceleration with respect to x, you get v final square minus v initial square by 2. This I told. So if I integrate from x initial to x final, I will get this. Now, if I see here, I am talking of uniformly accelerated motion where acceleration is constant. Okay, who is this? Deveshi Chengal. 40 minutes are left for SSC results. I know it is very important. So better you can leave the class and you can wait for your results, because this class can give you unnecessary tensions. Okay. So when we have acceleration constant, you can take it outside the integration. It will become a. Dx will become x. Here we have x initial to x final. Right? So what you will write here? A, x final I have taken as x. X initial I have taken as x naught. Look over here if you are not able to understand. X initial is x naught, x final is x. This will become v final. V final I have taken as v, v initial I have taken as u by 2. Now you can see what is x minus x naught. X minus x naught is nothing but the displacement, which is s. So if I finally cross multiply, so I get v squared minus u squared is equals to 2as. So this is our third important equation of uniformly accelerated motion. V square minus u square is 2as. So all the three equations you can see we have derived from here using calculus, that if acceleration is known to be constant, then s is equals to ut plus half at square. How we got this? Simply by integrating velocity with respect to time. If acceleration is constant, if we integrate acceleration with respect to time, we got the equation v equals to u plus at. And if acceleration is constant, then integrating acceleration with respect to position x, we got v squared minus u squared is equals to 2as. So when we teach calculus, the first thing application wise in physics we say that this is what you have already studied in 9th, 10th, the equations of motion for constant acceleration. This is how we can derive them by the help of calculus also. So just to show the importance of calculus, we are deriving it in this way. I hope it is clear to all of you. I think this girl Navya, I am seeing her again after few days, and she is more into making friends in the class instead of studying. So better make friends outside. The world is very beautiful outside. When we had nothing to do, no studies, nothing, early men, they used to live in caves. They were very happy. Every morning they woke up, went outside, whatever animals they found they hunted, then ate, made friends, slept, again next day same routine. Life was very happy. The moment you start studying, everything becomes very miserable. And these are those students who come over here to different campuses, be it boys campus, girls campus, then they come there and after that they will just be into friendships and all. And when the NEET exam will come, that time they will be writing, or we are very confused, we are fearful, what will happen now, and so on. Sir, should we learn derivation? It is up to you. If you want to learn, learning is never harmful. If you learn till now, I think whatever age you have attained, you have been learning throughout something or the other. Learning is never harmful. If you know the method, then you will know that for any case, if it is not a constant taxation in any case, you can find whatever is required. So learning will be helpful. Making too much of friends will be very harmful. So focus now. Next, what if acceleration is not constant? Now let's take situations where we have acceleration being variable. I mean, it is important. Means you are telling me, or what are you trying to say? Everything is important. Whatever I am telling here, it is important. If you just memorize things, you will forget. But if you know the concept, then it will be helpful for you. Even if you forget formulas, you can quickly derive them. So derivation is taught just to make you understand how situations arise and how to deal with them. If it is not important for you, it is your perspective, then you can leave it. If you feel that no, whatever is being told, it is important, then go for it. So coming next to question, suppose we have a situation where a particle moves along x-axis and some situation is given with a time varying acceleration a is equals to 2t minus t square. We are taking acceleration in meter per second square, time we are taking in seconds. So it is moving with an acceleration which is varying with time. In question they have mentioned some conditions. Initially it was moving at 2 meter per second and was at x equals to minus 1 meter. Find its number 1 velocity at t equals to 2 seconds. Number 2, position at t equals to 1 second. Number 3, or leave, position we have found, that we can find later. Now understand, the alternative for deriving equations of motion instead of using derivation and integration. If it is uniformly accelerated motion, you can find it by graph also. But if it is not uniformly accelerated, if it is variable, then you cannot use anything else except for this. It is not that, sir, is there any alternative that I am having some serious medical issue? Can I go for home remedy instead of visiting a doctor? So the answer would be no. For everything, home remedies don't work. You have to visit the doctor. Similarly, for everything, you cannot just go by shortcuts. There are some concepts which are to be learned, only then you can deal with such situations. Okay. If somebody is having heart issues, you cannot say that don't worry, just take bitter gourd juice, you will be okay. So he has to visit a cardiologist. So same over here. Now here, this is the equation given. Acceleration is variable. Once again, sir, please, 2 times folded hands. 2 times folded hands, 1, 2. Now we can come back. Okay. Graphical method can be used. Graphical method you can use, but graphical method also requires calculus. If it is a straight line, then you don't require calculus. But if the graph is not a straight line, then you will definitely require calculus. Once again, sir, once again. Okay, now look over here. So, velocity at t equals to 2, position at t equals to 1. And when acceleration is given as a function of time, so I told first they are asking velocity. So what I said, where is Satvik? Remove Satvik also. He is missing his relatives. Kindly send him over there. Now here, what we have, understand, it is not that randomly I am writing a question, so I will just be writing the solution. Randomly we won't do anything. First you have to see that what is given. Try to understand everyone. Any comments now, if you send, I will simply just stop and make myself static. You don't learn anything, you don't wish to learn anything, it is up to you. But if you are listening carefully, don't type anything till I ask you to. See here. When we have got questions like this, first you think what is given, what is asked. Then you will understand whether integration or differentiation is needed. Especially for those students who are continuously, sir, once more. Listen carefully. Don't type. Acceleration is 2t minus t square. What is the strategy? I am telling it just like a basic student approach should be. And once you understand, you can do it orally also. Now here a is equals to 2t minus t square. This is given. This is given. Understand, this is given. So acceleration is given as a function of time, first of all. Second thing, they have given some information. When they give information, always write it. What they have given? These are the given parts. One is this. They have given initially. When the word initially is used, that means t equals to 0. Initially means t equals to 0. When t was 0, they have given it was moving at velocity. That means they have given the velocity 2 meters per second. And they have also given the position x is equals to minus 1. These are given values. Clear? Acceleration is given as a function of time. At t equals to 0, velocity 2 meters per second, x is equals to minus 1. These are going to help you to take the limits of integration if required. I have still not told integration is required or not. Next, position at time t and velocity at time t. At time t equals to 2 seconds, they are asking what is the velocity. At time t equals to 1 second, they are asking what is the position. So let's see one by one what is required. First this one is required, second this one is required. Now what I will say, t equals to 0, velocity is 2. T equals to 2, what is the velocity? They are asking. That means I should need velocity as a function of time. Arey bhai, if you have velocity as a function of time, then you can say now that what is the value of v at t equals to 2. So what I need first for this, velocity as a function of time is needed. Then only, if you have an equation, then only you can solve. So here acceleration is given as a function of time, and to get the velocity at t equals to 2 seconds, I need velocity as a function of time. Then ask yourself, how can I get velocity as a function of time if acceleration is given? So immediately it will come to my mind, acha, acceleration is given and velocity is required. That means I have to integrate. So I know since acceleration ka integration with respect to time from t1 to t2 will give you change in velocity, means v2 minus v1. Did I say this? So now I can say that if I integrate acceleration which is given 2t minus t square, if I integrate with respect to time from where to where, one time is given t equals to 0. If I want as a function of time, let's call it as t. This side I will write v at time t minus v initially, v at t equals to 0. Initially velocity is given as how much? 2 meters per second. This value is given as 2. So from here, if you integrate 2t will become t square by 2, 2 cancels, minus t cube by 3. This side you will have v minus, at time t I want v, initially the velocity has been given as 2. So we can see velocity as a function of time, it becomes t square minus t cube by 3 plus 2. So did you get velocity as a function of time? Once you get velocity as a function of time, now your work is over, first part. At what time beta they are asking? At t equals to 2 seconds. When t equals to 2 seconds, just substitute t as 2. So when you will substitute t as 2, you get 2 square minus 2 cube by 3 plus 2. So this will become 2 2s are 4 plus 2 6 minus 8 by 3. 6 3s are 18 minus 8, 10 by 3 meter per second. Once you know the method, you can solve it just in one line. Integrate acceleration, you will get change in velocity, we can find velocity. So what I am saying is, if you integrate acceleration from t1 to t2, you get this. So what I have done over here, I have taken t1 and t2 as what? I have taken integration from 0 to t. Why did I take 0? Because they have given me the value of velocity at 0. And here when I am writing v2 minus v1, means it is the velocity at time t equals to t minus initial velocity. This is what I am writing. So I know the initial velocity. In question they have given me 2 meter per second. So velocity as a function of time I got. Once I get velocity as a function of time, then put the value t is equals to 2 seconds. Once you get t equals to 2 seconds velocity, this is the answer for first part. Is it clear? Now what we do, we have another part also where we have to find the position. We have to find the position. Take a screenshot fast so that if anyone has any confusion, you can quickly look into it. Because we won't be getting that much time that again I will go back to the page and explain. Okay. So this is done. Now second part, position. Again I ask myself, suppose I am a student and I ask myself, acha I need position. Second part is I need position. T equals to 1, they are asking x equals to how much? T equals to 0, they have given x. So I will say x as a function of time is needed. Beta, if you find x as a function of time, then only now you can find the value of x at any time. Then for second part, what I will do, I have to find x as a function of time. I have velocity as a function of time. Ask yourself, if velocity is given as a function of time, how do I get position? I told when you integrate velocity with respect to time, you get change in position. I said this or not? T1 to T2. So if I know this, this means if I will integrate velocity with respect to time from 0 to t, then I will get x at t equals to t minus x at t equals to 0. In the question, they have clearly mentioned that at t equals to 0, particle was at minus 1. At t equals to 0, particle was at minus 1. So this value they have given us minus 1 meter. Now let's integrate here. Velocity integration, just one line. T square, see over here. Don't say once more. See here. Velocity is this, I have to integrate directly. T square will become t cube by 3 minus t cube will become t to the power 4 by 4, but there is a 3 also, so 4 3s are 12 plus 2 is alone. When 2 is alone means 2 dt will become 2t. Yesterday we have seen all these examples. 2 dt will become 2t on the left hand side. Now you will say, sir, there is limit also, why are you not taking limit? Put the limit. If you will put t, you will get this. If you will put 0, you will get 0. So you will just get this only. Right hand side, you are getting x minus of minus is plus 1. See here it is minus 1. Minus will become plus 1. So what is x as a function of time now? Take it on the other side. So we have t cube by 3 minus t to the power 4 by 12 plus 2t minus 1. This is x as a function of time. So second part, they are asking find the value of x when t was 1 second. So if I put t equals to 1 second, so I get the position as 1 by 3, put t as 1 by 3 minus 1 by 12 plus 2 minus 1. So when we see from here, one by 3 minus 1 by 12 plus 2 minus 1 is 1. Take the LCM as 12. So here you will get 4. Here we will get 1. 4 minus 1 is 3 and plus 12. 3 plus 12 is 15. 15 by 12 means 3 5s are 15, 3 4s are 12. 5 by 4, 1.25 meters. 1.25 meters. Yes, correct. 1.25 meters. Understood? So if one of the terms is given and you need to find the others, you should know which equation to use and where to use. Correct. 5 by 4, which is 1.25 meter. I hope this is clear. So when we have questions where some information is given, I always insist the students should note them like this, that these are given, what is required. Then you know the basic equations, what to use, whether to integrate or differentiate, you will quickly get your answer. Okay. So from here, acceleration to velocity, from velocity to position. And I always insist find the velocity and positions as general functions of time. Once you get that, then whatever time or whatever they ask you, you can put and get the answer. Right? Now let's move to our next question. I am taking general equations, so it means that it can be based on integration, it can be based on differentiation. So I will randomly put values, and but you have to be clear with whether we have to integrate or differentiate. Let's see the next question. For a particle along a straight line, velocity is t square minus 4t. Velocity is given in meter per second, t is given in seconds. Now we have to find number 1, acceleration as a function of time. Number 2, displacement during t equals to 2 seconds to t equals to 3 seconds. And number 3, time intervals when the particle is retarding and in which it is speeding up. Now those who have been sincerely attending the classes, you will understand we have discussed all these things. What is the meaning of retardation? What is the meaning of speeding up? So we are covering these 3 points, very important question which we are covering the points. They have given velocity as a function of time. First they are asking acceleration, second they are asking displacement, and third they are asking the time intervals in which the particle is speeding up and where it is retarding. Now see first thing. If I see first part, what they have given me velocity t square minus 4t is given as a function of time. So first part they are asking acceleration. So what do we know? Acceleration is found by integration or differentiation. You will say, sir, if velocity is a function of time, then we know we just need to differentiate, that's it. So it is not that we are randomly putting integration differentiation. So I will say acceleration is asked. So acceleration is dv by dt, that's it. So dv by dt, t square will become 2t and 4t will become 4. Simple, 2t minus 4. So first part is done. Now comes second part. They are asking displacement. Now you will say, how to get displacement from velocity? Shall I differentiate? You will say, no sir, you told that if I integrate velocity with respect to time from t1 to t2, then I know it is x2 minus x1, which is called as displacement. You told this. I said yes. So I will integrate here. So I will integrate velocity from where to where? They are asking 2 to 3 seconds. So if I integrate, so displacement they are asking from t equals to 0 to, t equals to 2 to t equals to 3, then I have to integrate the velocity from 2 to 3, that's it. Now direct integrate t square you will say, sir, t square you know, t cube by 3, 4t, t will become t square by 2, listen again, t will become t square by 2 and there is a 4. So here we have 2t square, 4t square by 2 means 2t square. Array, differentiation of acceleration you won't get velocity, differentiation of velocity will give you acceleration. That's why I told take screenshot. Who is this? Venkateshwarlu. That's why I keep on insisting that while I am teaching something, take screenshots. Everything we have written over here. See, acceleration function of time, integration gives you velocity. How will you get differentiation as velocity? So while being told, act accordingly, things will become easy for you. Right? So here we get this. Now you will say, sir, limit also is given and you have to put the limit. Yes, yesterday we discussed about definite integration, how to put the limits. Now first I will put 3. T as 3. So 3 cube minus, now I will put 2 cube by 3. Then in second term, t square, I will put 3 square and 2 square. So from here, 27 minus 2 cube, 8. So it will become 19 by 3 minus 3 3s are 9 minus 4 5, 5 2s are 10. 19 minus 30 minus 11 by 3 meter. I have said earlier also displacement can be positive, negative, 0, whatever. So here we are getting minus 11 by 3. I hope I have done the calculation correctly. Check from your end. 27 minus 9. 8. 27 minus 8 is 19 by 3 and we have here minus 10. So 19 minus 30 minus 11 by 3. Are the two parts clear to everyone? Yes, minus 11 by 3. Are the two parts clear? Because we are finally going to see the most important part, a very beautiful application of calculus, when they will ask you that for a general motion, how can we know particle is speeding up or retarding? So coming to the third part, I have told you, just making you recollect once again. Did I tell you if acceleration and velocity are in same direction, same sign, then only you say speeding up. And when acceleration and velocity are of opposite sign, one is positive, one is negative, or vice versa, if they are of opposite sign, means force and velocity are in opposite direction, so it is only called as retardation. Remember this. So I have written once again, acceleration and velocity of same sign, speeding up. Acceleration and velocity of opposite sign, then it is retardation. Remember this. Let us quickly see a response. FF team, you are wrong. It is not 2 seconds. Read the question carefully. I have written interval. Now see here, just respond to this important thing which we had discussed earlier, that how to check for speeding up and retardation. So now we come to the final part where we have to check this. So for that we have to check the sign of acceleration and velocity. So see how we do that. It is very simple thing to do, slight mathematics. Velocity is given as t square minus 4t. I hope kindly write in your copy, otherwise you can forget. I am doing one thing. Take a screenshot fast. Take a screenshot fast of this so that no one gets confused. You have that thing with you. Take a screenshot of this page so that while I am doing the last important step, no one gets confused anywhere. Okay. I hope this is sufficient time for taking a screenshot. Now, V is given as t square minus 4t and I have found acceleration as 2t minus 4. Check here. So how we proceed with the last part? Their sign you have to compare. V is equals to t square minus 4t and acceleration we got 2t minus 4, right? Let's check the sign. I will say acceleration will be positive if 2t minus 4 is positive. That is 2t should be greater than 4, so t will be greater than 2 seconds. So acceleration will be positive if t is greater than 2 seconds. I am making you understand in step by step. Once you understand, it also can be done in just one line. But you need to see everything. Acceleration step by step. Where is it positive? When 2t minus 4 will be positive, means t greater than 2 seconds. So therefore we can say for time less than 2 seconds, acceleration will be negative. Can we say or not? Time less than 2 seconds, acceleration will be negative, and time greater than 2 seconds, acceleration will be positive. Same we will do with velocity. Velocity is t square minus 4t. So velocity will be positive if t square will be greater than 4t or t will be greater than 4. Time cannot be negative, so we have to take only the positive value. So t greater than 4 seconds, velocity will be positive. So therefore, for t value whatever is less than 4 seconds, velocity will be negative. So once you get this, and I know this thing, so see, I am explaining in a very simple way, and beyond this I cannot explain. I am very sorry for that. If you don't understand here, then I won't be able to, but if you know that yes sir, this is a easy concept, then definitely you will understand. Now see the times. Acceleration is changing its sign at t equals to 2, greater than 2 and less than 2. You are seeing acceleration is changing its sign. So I am marking that time here. Time can never be negative. Acceleration is changing its time at 2 seconds, greater than 2 positive, less than 2 negative. And velocity is changing its time at 4 seconds. So I am marking that also. Now comes the real part. Less than 2, 0 to 2 means less than 2. Less than 2, what is acceleration? Negative. You will say sir, acceleration is negative. Very good. Less than 2 is less than 4 also. If time is less than 2, then time is less than 4 also. Less than 4, velocity is negative. So less than 4 seconds, velocity is negative, means here velocity is negative, here velocity is negative. So less than 2, acceleration is negative, greater than 2, acceleration is positive. You can check, greater than 2, acceleration is positive. So here also acceleration positive, here also acceleration positive. And greater than 4 seconds, velocity is positive. Bas, you got your answer. Now check. I told whenever same sign speeding up, whenever opposite sign retarding. Here A and V both are negative but are of same sign. They are of same sign. If they are of same sign, means here the particle speeds up, where in between 0 to 2 seconds particle is speeding up. If you see greater than 4 seconds, again same sign, Means here again we have the particle speeds up, and in between 2 and 4 seconds you can see acceleration and velocity are of opposite sign. If they are of opposite sign, that means this case here retards. So if they ask me which is the interval, yes, less than 2 seconds and greater than 4 seconds, the particle is speeding up, its speed is increasing, whereas in between 2 seconds and 4 seconds the particle is retarding, that its speed is getting lesser. Is it clear? So did you see a beautiful application of calculus where if they give you velocity and they ask you that can you tell whether the particle is speeding up or slowing down? The only thing that you have to do is beta, just differentiate and get acceleration. Once you get that, then make a simple column, or you can do it on a straight line only. Check where they are of same sign, where they are of opposite sign. Velocity positive, this term should become positive, you get the time range. Velocity negative, you get the time range. If you get positive, you get negative here. Acceleration, where it is positive, where it is negative, you got that. Once you got that, just on a simple number line mark the times. Then wherever you see they are of same sign, the particle is speeding up. Wherever you see they are of opposite sign, the particle is slowing down. So I hope this interesting application of calculus, differentiation and integration, what we studied, this thing is clear to all of you. Lot many problems like this will be discussed in physical classroom when you all will be joining at your respective centers. But just to give you an insight of what all things we should know, how we can apply them, it is not random blabbering or random doing that, yes, here I will differentiate, here I will integrate. No, everything has a reason. Where to integrate, where not to, where to differentiate, where not to, all these things should be clear to us. So on that note, I will be ending today's class. So kindly go through this class. It is a very important one. When you are reading, make a notes of it, proper note of it, and see the video again and again if you don't understand any step. So that will be all for today. In next class, we'll be seeing, I think 1 or 2 classes more are left. In that we will be seeing some elementary concepts of vectors. Okay, so that's all for today. Have a good day. Thank you.